Hello everybody, so this is Mr. Bowman. We're going to be looking at the ALEKS topic, an informal proof of the Pythagorean theorem. So we know the two sides of our right triangle here. We have a base of 6 and, a leg of 6 and a leg of 11. And we're going to try and find that hypotenuse. So what they're going to do is we're going to take 4 copies of this and kind of put them all around here. So point to point, so they end up making a square. So if you can see, this is 6 and it's 11, we get 17, right? So this is a square, so 17, 17, 17, 17, and the inside is another square because it's all of those hypotenuses of C that I don't know the numbers of. But since they're all C, then they will also be a square, even though I don't know exactly what it is. All right, so compute the total combined area of the 4 triangles. So if I look at these, one triangle would be 1/2 base times height, so 1/2 times 6 times 11. Okay. So if I multiply those together, 1/2 times 6 is 3, so 33 units squared, whatever, but I don't know that yet. So I'm going to just put units. Compute the area of the large outer square. All right, so our big one, pretending this was all filled in, would be 17 times 70. Oh, sorry, that was only one of them. There are 4 of them, so I need to multiply that by 4. That would have been problematic. So this is actually 132 units squared. Okay. Since it's 33 for 1, then I have to do 33 plus 33 plus 33 plus 33. All right, so now jumping to this one, that's 17 by 17, so that gives me 289 units squared. So C squared is going to be our big one, right? So the big thing minus the green bits, and then it'll leave me with the leftovers. So 289 minus 132 is 157 units squared. Okay, so if I just straight do this, a squared plus b squared, so not actually doing it for my picture, but just there. So if I do a squared plus b squared, that'll be 36 plus 121, which does get you 157 units squared, which are equal, right? And that is where we get one way you can show that we're doing the Pythagorean theorem. A squared plus b squared equals c squared.